I'm going to start a brand new space eco voyage, and remember that you are in charge of a multi-year voyage to Mars. You know, it takes like 8 months to get there at current technology, and 8 months to come back. That's almost 2 years, and then spending time getting a colony, 3 years, 5 years maybe. So you have to bring all your plants, all your animals, and let it be sustainable, just like we saw in the Martian movie, how he got stranded there and then he was trying to grow his own potatoes, stay alive long enough for a rescue mission to come and help him. That's kind of the scenario here. So you have to deal with biotic factors, all the living plants and animals, and abiotic factors with nutrients for your soil, the right temperature, and things like that. So it's kind of particular, so I'm going to get you through a couple of tricky spots. So maybe you've already done this, but if you didn't earn 100%, then go back in and do it again. This is a lab grade, so you want all of your points available. If you continuously turn in something less than the 100%, it starts to add up. It gets hard to get an A if you've settled for B's and C's throughout the semester, especially in quizzes and lab work. So the tropic level means the food chain. Producers are plants. They take the sun's energy and make sugar, and they feed the primary consumers, which are herbivores. They eat the plants. Then you have secondary consumers that eat the primary consumers, and tertiaries are like at the top of the food chain. If you're flying your mission and you didn't set this up right, they're going to tell you, only 10% of the energy flows from one area to the next. It's kind of like a food pyramid right here. P for primary producers. They're at the bottom of the ecosystem triangle. They're the most massive, the most numerous, the most cells. They feed everybody else. But about only 10% of the plants get eaten by animals and then become part of their bodies. The rest is either lost as heat. Isn't it interesting that we are so warm compared to the room? The room's about 72 degrees, and you are 27 degrees warmer than the room. Where does your body temperature come from? From the food that you ate. Every one of your cells has mitochondria and is taking the food, specifically glucose, and then making ATP, but it creates all this body heat. So a lot of the energy is also lost as heat, and it's just gone. But only 10% of the energy goes into the bodies of the herbivores. And then similarly, 10% of the energy goes into the secondary consumers. So you take this starting number, 125, and you multiply it by 10, which in effect, 10%. So it's like multiplying by 0.1. That's taking away a zero. You can't use commas. I found that is a big problem. It will not allow you to fix any errors that come up during your flight. You cannot type it 12,500. I think I may have told you to do that, but running the game, now we realize that you have to make it a true number and not with. So it's 12,500 with no commas. The next one is 1,250 with no commas, and then 125. You have to have that or you'll have some issues. So the most massive, so if you start eating some of these, we know that 90% of them aren't going to be used anyway. They die and decompose. So eating down at this level is not going to affect your food pyramid. So that's the one that you choose right there. You are going to eat producers. If you start eating the consumers, your food web's going to fall apart. So we're done with that. Then we go to the waste. And all living things give off waste, as you know. We're exhaling carbon dioxide, urine, and feces. So it might gross you out. So you're going to go, yeah, I'm going to jettison these into space. I don't need them. Yuck. But the minute you do, now you are taking away from your ecosystem and it will degrade and fall apart. So you have to have bacteria and fungi. These are organisms that will eat dead, decaying matter. So throw nothing away. Everything gets reused. So go through everything, keep it on the ship, make sure that plants are going to use it for photosynthesis, and then you're done. Biodiversity means that you have to have a variety of life. In order for an ecosystem to be healthy, it should have a good variety. And otherwise, if something happens to that one species, it wipes out everything. So biodiversity refers to the variety of life in an ecosystem. That's true. Which is more diverse, 2 million corn plants or 150 animals that are in 5 different species? It's not the number, it's the variety. So an environment that has 2 million plants is not more biodiverse. So that's false. Relationship between different species are very important. Losing a species could cause a ripple effect with all the others, and that's true. High biodiversity helps to ensure ecosystem resilience, meaning healthy and stable. They're healthy, that's true. Based on your answers, you seem to have a good understanding. All right, we want high biodiversity on our ship. Moving on to symbiosis. There's 3 relationships when organisms live together. Tapeworms, ticks, and protozoans that cause diseases like malaria. They get their nutrition from other hosts, and they might harm them or even kill them. These are examples of parasites. A spider that builds its web in a tree, he's not hurting the tree, or he's not helping the tree. They're just living together. That's called commensalism. And if organisms both help each other, that's mutualistic benefit. That's mutualism. The bee is visiting flower to flower. The bee is going after nectar, which is sugar water. When the flower opens, it produces sugar down to the bottom of the flower to have the bee or insect go down there, and they're bumping the stamens on the way down there. The stamens are filled with pollen, which contains the sperm. They get it all over them. Then they go to another flower and they hit the pistil of a female flower and they put the pollen on that. It's sticky. They don't even mean to do it, but it's a tight quarter in there, and they end up putting the pollen of one plant onto the pistil of another, and they fertilize it. That helps the plant, and the bee is getting fed at the same time with the nectar. That's mutualism. So, select which ones we want to bring. Everything but the harmful one. So, mutualism and commensalism. No parasites. Here's another tricky spot, just like that one with the tropic levels with no commas. We have honeybees. We have other insects. And when I first looked at this, I didn't look at the white. They should have made it a different color. So there are 3 pollinators. Sometimes other things other than insects. It could be like a hummingbird. So you have bees, other insects, and then for some crops like soybeans, wow, it really takes another animal. So now if we look at the next question, based on the data from that graph, yeah, we want honeybees. We want other insects, but don't forget, other insects, but don't forget the other non-insect pollinators. Sometimes they're 90% of the pollination. So you have to bring all 3 on board. Then we go to abiotic factors, looking at temperature. All living organisms operate at a certain range of temperature. Do you know the range of temperature for you? You're at 98.6 degrees. Is it okay for you to be 97? Yeah. Yep. 96? Yeah. Maybe not. 95? You're probably approaching hypothermia, right? How about 99? No. Yeah, that's maybe a half a degree, and you're starting to feel like, oh, I don't feel good. And you're only a half a degree temperature over normal. How do you feel when you have a 100-degree temperature? You can feel that you're hot. You're used to your normal temperature. How about 101? You're calling in sick. 102, you can barely get out of bed. 103. Yep, now you're starting to wonder, maybe I need to go to the hospital. 104, especially for young kids, time to go to the hospital. And that's only 5 degrees warmer than normal. Why is high or low temperatures bad? Because we're walking chemistry sets, and the chemical reactions only work at certain temperatures. Temperature is really bad for enzymes. Enzymes speed up chemical reactions. Life is not possible without enzymes, and so if you start to damage your enzymes, those are proteins, they denature. They're globs and they only work, but when the temperature gets hot, they flatten out and they no longer work. That's what frying an egg is in a frying pan. It looks white when you first crack it, the egg white anyway, and then it really turns white. You know, it's translucent when it's right out of the egg. That's the way it should be, but when it gets cooked, it denatures and flattens out and changes color. So that's kind of what's happening inside you when you have a temperature. Why do we get a temperature? That's our body's mechanism to cook bacteria and viruses and other pathogens out of us. We crank up the temperature to try to fry them inside of us. But if you keep your temperature up too long, it starts to fry your own cells, denature your proteins, and you're messing with your chemistry, which can lead to organ failure. So we can only have a high temperature for a short amount of time, otherwise it starts hurting us. So now look at this chart right here of temperature. When you first look at a chart, 3-second rule, right? Can you get information out of it in 3 seconds? Yeah, if you look at the x-axis, temperature, low, high, growth, low, high. So you want to be high up here for growth. So over here it says 2 kilograms a week of growth for your potatoes. There's 2, and it's not quite at the peak, but it's right here and right there. So if you were to draw a line going down there, that's what the green thing is. It shows maybe it was 15. Looks like I'm going to write 16. So it said, write this down. So for potatoes, I'll go 16 to 22. Everybody got that? Then you go to the next one, and it's wheat. And that one right here would be 22, 21, and 27. 21 and 27. So what's the overlapping number? 22. If we go higher than that, we're hurting potatoes. And so that is the good number to use for both of these guys. So 22 degrees would be really good. And this is Celsius. To keep it in perspective, room temperature, it's called 68 degrees, and that's 18 degrees Celsius. So 22 is somewhere around 75 degrees Fahrenheit. Yeah.
I was going to say, like, the temperature of the bodies, it's kind of like hot, all the oil inside
Right. Yeah. And our engines are at like 300 degrees for gas engines. Okay, we're done with temperature. How about light? Then you go over to light and you look at this chart right here. It says analyze. We need to Amount of light, and on the y-axis, this is the average growth. So we want to give enough light for everything to grow, and that would be right about here, right? About 12 hours of light. So if we were to go over here, then, you know, that might use a lot of batteries, and we're not getting any increase in growth if we increase the light. But we need it to probably be 12. Let's see what 12 does. Then you go over here to atmosphere, and you could simply do a Google search, right? So you're going to go and you'll go what are the atmosphere gases? 78% nitrogen, 21% oxygen. Isn't that amazing that oxygen is only 21%, yet that's what we need to breathe? If you're a scuba diver, they don't fill the tank with 100% oxygen. That's what they have like on the sidelines of the football game. More oxygen. But yeah, I don't know if that's even 100%, but it'll be more than 21%. If you're a scuba diver and you get your tanks filled, they're going to put 71% nitrogen, 21% oxygen. Was it 28? It was, did I read the number wrong? It was 78 and 21. Yeah, I thought that wasn't right. 78 and 21. And so that leaves 1% for other stuff. And then minerals. Have you ever gone to Home Depot and helped get fertilizer? What is in fertilizer? Nitrogen, phosphorus, and potassium. So we go over here. Nitrogen is N, capital N. Potassium is P, and nitrogen, phosphorus, and potassium is K. Yeah.
Is it potassium K?
Yeah, I did. Nitrogen, phosphorus, and potassium K. There are also secondary macronutrients and micronutrients, and so it turns out that you need everything. So here we are with the chart, and we have to have, these are nutrients down here, and this is the growth. So in order for good growth, we have to at least hit this curve right here. That's the critical nutrient range where no symptoms are. And this is just all luxury. Adding more, going that way, doesn't help, but it starts to hurt if you add way too much. So if you add too much fertilizer, you can burn your plants. They die from having too much fertilizer. It becomes toxic. But they'll also get yellow and not do well if you don't have enough. So you've got to at least hit that critical range. So then the answer is, how much fertilizer and nutrients should you have? Add enough of each so you have maximum growth, but you don't want to poison them. That sounds pretty good. Add the maximum. The more the better. No, if you start adding more, it becomes worse. Add very little. That sounds like you haven't added enough. So the right answer is add just the right amount. After you get all 8 of those, it gives you the space voyage. So then you can fly the mission. Here's what you turn in. You go to the main menu, and you're turning in your score sheet. You turn this in. You have to turn it in 2 ways. This is written at the assignment. You're going to submit the score right here inside of the game by hitting submit the score to the teacher. My email address is all over our Canvas page. There it is, jreynolds@modernday.org. If you check that email, yep, I'm there. And then you type your name. You'll type your first name and your last name, and then your class period. Upload your score.
Do we do this
You also, the directions say, take a screenshot. You know how to do that. Now you have a picture in your camera roll and you turn that picture in at Canvas. Everybody got that? So now I'll give you the class time to work on the Space Eco Voyage first. This is due on Monday the 27th. I think you can finish in class because now I've set you up for success. Then work on your biome newsletter and I'll help you with that. So I'll come around and help you if you need it.